Now let's look at solving quadratic inequalities. So first let's look at an example, and then we'll write down our steps. So solve x squared plus 4x minus 12 is less than or equal to 0. So what we notice here is that this is an inequality, but it's not a linear inequality, it's a quadratic because it has a squared term in it. So here are the steps. The first step is we're going to find the critical values, which are essentially the X intercepts. Now let's think about why. If we have a parabola, the only time that it's going to be able to change from positive to negative is when it crosses the x-axis. So that's what we mean by the critical values. We're going to find the x-intercepts. And the way we're going to do that is we're going to rewrite it ax squared plus bx plus c is equal to 0. It's actually going to be greater than or equal to 0, less than or equal to 0. You have to remember the sign flipping rule. The second step is we're going to define test regions. And in general, we'll have, with a quadratic, we'll have 3. There are some exceptions, but in general we'll have 3. And then the third step is we're going to test the regions. And that hopefully will be very clear in just a second. So find the critical value, define the test regions, and then test those regions. So let's do an example. The first thing we do is we want to solve for the x-intercepts. Make sure everything is on one side equal to 0. This is. Then either solve by quadratic formula or factoring. So either solve by quadratic formula or factor. If you can't factor, you have to use quadratic formula. This one I believe you can factor. I think that's, let's see, c is negative, so that's going to be a plus and then negative. What two numbers multiply to 12 and add to 4? Let's see, 12, it's going to be 4 and 3. That doesn't work. 2 and 6 works. So that's going to be a plus 6 and a minus 2. And that's going to equal to 0 at x plus 6. We're going to solve for the x-intercepts. X plus 6 equals 0. X minus 2 is equal to 0. So x is minus 6 or positive 2. That's your first step. These are your critical values. That's not your answer, it's just your critical values. Next we're going to draw a number line, and I'm going to go do this on a separate sheet of paper, but we're going to draw a number line. So we get x equals minus 6, x is equal to positive 2. So draw a number line, minus 6. Positive 2. You have to think about, can it equal to? That you have to think about that's going to be closed dot or open dot here. Let's look at our problem. It's less than or equal to, so those are going to be closed dots. This will be a closed dot and a closed dot. And then it defines 3 regions. I'm going to draw a dotted line here and a dotted line here. What that means is I know that since this is a 0, in this region here, it's either all going to be positive or all going to be negative. The same thing between these 2 points and here. And these are my test regions. My test region is 1, 2, and 3. So now what I'm going to do is I'm going to look at my original problem, which is x squared plus 4x minus 12 is less than or equal to 0. And I'm going to test x squared plus 4x minus 12 is equal to 0. So I'm going to take any number between minus infinity and minus 6. Doesn't matter which number you use. It just has to be in that region or interval. I'm going to choose x equal to minus 8. And I'm going to plug this in and see if this region is positive or negative. That's a minus 8 squared plus 4 times minus 8 minus 12. That's going to be a positive 64. That's a minus 32 minus 12. And I actually don't care what the number is, I just care if it's positive or negative. That's going to be 64 minus 32 is 32 minus 12 is going to be 20. This is 20, so that means that all of this region is positive. I'm going to do that for each region. Here, I'm going to test some number between minus 6 and 2, any number I want to. I'm going to choose x equals 1. And then I plug in x equal to 1 into the inequality, so I get 1 squared plus 4 times 1 minus 12. 1 squared is 1, that's 1 plus 4 minus 12. That's 5 minus 12, or minus 7, I think. That's going to be negative, so everything in here is going to be negative. My third region is here, so choose some number between 2 and infinity. It doesn't matter which number. I'm going to choose x equals 5 and plug it in. So then you get 5 squared plus 4 times 5 minus 12. 5 squared is 25 plus 20 minus 12. I can already see it's going to be positive. That's 45 minus 12 is 33. That's positive. All that's positive. So that's step number 1 and 2, right? Step number, and 3 for that matter. Find the critical value, define the test regions, and test the regions. I've done that. The last step is I simply solve. I want to know when it is negative or 0, right? I want to know when it's less than or equal to 0. When is it less equal to 0? In this region right here. So my answer is going to be minus 6 to positive 2. So the easiest way to write that is probably in interval notation. My final answer here is going to be minus 6 to 2. It includes minus 6 and includes 2. So they're going to be closed brackets for both. And that's how you do quadratic inequality. Let me do one more example, and then if you want more examples than that, there's another following video that you can watch. Let's solve 2x squared plus 5x greater than 12. The first thing to do is rewrite this. It's going to be 2x squared plus 5x minus 12 is greater than 0. I'm going to need to first solve for the zeros, solve for the X intercept. They're called critical values in this case. In this case, I can either use quadratic formula or factoring. I think this is going to be 2x and x. There's going to be a plus and a minus. I probably could just kind of figure this out. 2x and x. 6 and 2, that's 6 and 2. That's going to be, let's do 2, that's 4 and 6. That doesn't work. Let's try a 6 there. That's 12 and 2. 12 and 2 is 10. 4 and 3, I bet. Let's try 2x, x. If it's 4 and 3, there you go. That's going to be 3, and that's going to be 4. That's going to be 8, and 3 is 5. You want this to be negative and that to be positive. You can also use AC factoring. That's probably the best way to do it, but you can always check yourself. This is 2x squared minus 12, 8 minus 3. Perfect. The critical values here are going to be 2x minus 3 is equal to 0. X plus 4 is equal to 0. So it's going to be positive 3/2 or minus 4. Now you're going to do is you're going to draw a number line. The number line is going to include these 2 points. So it's a minus 4 and a 3/2. The trick here is that since this is greater than this, the key here is you're not going to use the original problem. You're going to use the one in which you have got it greater than or equal to 0, or in this case greater than 0. Strictly greater than. You're going to put an open dot there and an open dot there. Now we can save a little bit of time since we know that the parabola is either going to go like this or like that. We actually only need to test one region if we have to. So let's choose this region here. Let's plug in 2x squared plus 5x minus 12 is greater than 0. Let's choose a minus 5. So that's 2 minus 5 squared plus 5 times minus 5 minus 12. Minus 5 squared is 25. It's a positive 25, so that's 50. Minus 25 minus 12. That's 50 minus 25 is 25 minus 12, which is going to be 13, so this is going to be positive here. This is a parabola, so you know it's going to come down like this, like that. So this is positive, this is going to be negative, this is going to be positive. We want the cases when it's positive. So this is what our answer is going to look like graphically. It's going to be minus 4, 3/2, open dot, open dot. That's from minus infinity to minus 4, but it's not going to include minus 4. And it's going to go from 3/2, but it's not going to include 3/2 to positive infinity. And it's both of those. So there's your final answer right there. So that's how you do quadratic inequalities. There are some trick problems, but there's another video that says more quadratic inequalities and another video that says quadratic inequalities with tricks.